Hello everyone. So today we have the problem maximum units on a truck. This is a very interesting problem. This problem is going to teach us when to think greedily about a problem and when to think of using dynamic programming in a problem. Okay. So let's read out the problem statement first. You're assigned to put some amount of boxes onto one truck. You're given a 2D integer array of box type where box of I denotes number of boxes of type I and number of units per box I. So this is the same thing that I said. Now you are also given an integer truck size, which is the maximum number of boxes that can be put on that particular truck. Okay. So you can choose any box to put on the truck as long as the number of boxes does not exceed truck size. This is a very important line. Now return the maximum total number of units that can be put on the truck. So this is the problem statement. Let's try to understand it using the diagram that I have created. So this is the 2D array that we were given in the question. So the first element was 2, 3. The second element was 2, 2, and the third element was 3, 1. Okay. So what does this 1, 3 denote? This 1, 3 denotes that the first parameter, the first value here, it denotes that how many boxes are there of this particular type, and the second value denotes that how many units are there in this particular box. Okay. So there is one box only and 3 units are there in this particular box. Now we go to the second one, and here we have 2, 2. So 2 boxes are there of this particular type having 2 units each. 3 boxes are here of this particular type and having 1 unit each. Okay. So, and the truck size that was given to us was 4. So we can put maximum 4 boxes from here on the truck, and we need to maximize the units that can be put on the truck, right? So this is a very simple problem. Now let's think about it. So if we want to maximize the units, okay, there's circles. If we want to maximize these circles, so we will obviously pick all those boxes first, which is going to have the maximum number of units inside them, right? So we take 1, 3. There's just one box, so we take 1, 3. So the space is taken, and in our answer we have 3 units since there were 3 circles. Plus now we are still left with 3 spaces. Okay, so 3 boxes can be taken from these many boxes that are here. So second box we take of having 2 unit, and this box also, these 2 boxes are also taken. So these 2 spaces are also filled. Okay. Now 2 unit each in 2 boxes. So there are total 4 units that we accommodated on our truck. Now 4 plus the last one, we are left with 3 boxes having 1 unit each, and we have just 1 space to fill 1 box. Okay, so we take 1 box and we leave the remaining 2 boxes here. So this is also taken. Now we have 1 unit that we accommodated. So 4 plus 3 plus 1 gives us 8. So the idea is to take all the boxes that are going to maximize our chances of getting the maximum number of units, right? So we try to take this box, this box, this box, and then this box. So in total we have 4 places to put 4 boxes, and we utilize all the boxes that can potentially give us the best answer, right? So this is the solution to this problem. Now we will try to compare this problem with 0-1 knapsack problem. So in 0-1 knapsack we were given some weights of the items, and we were given the values associated with the weights, and we were given a total capacity of the bag. Now in this problem and the 0-1 knapsack problem, the major difference is that in the 0-1 knapsack problem, if we want to take any item, we have to take the entire item. Okay, We can't leave some boxes. If this problem was to be modified like a 0 1 knapsack problem, then if we want to take this box 3 1, we can't take just one box and leave two boxes. And if we want to take it, then we have to entirely take this item, or we have to leave this item. So that's the difference between this problem and the 0 1 knapsack problem. So why greedy works here? Because if we are allowed to take the boxes that are going to maximize our profit, then we will always go for the boxes that are going to give us the maximum profit, right? But in case of DP, that 0 1 knapsack problem, we will try to find all possible solutions to the particular problem, and then we will try to identify the best possible path that is going to lead us to our desired solution. So this is the major difference, and let's try to see the code now. So first of all, we are trying to sort the 2D array that is given to us, which is box type, on the basis of second element in decreasing order. And why we are doing so is because if the array is sorted on the basis of second element in decreasing order, then we can take as many boxes as we can of that type which is having the maximum number of units in them, right? So this second parameter denotes the number of units, right? So we can take them as many boxes as we can of the type which is going to lead us to the best maximum profit that we can make. Okay, so first line is going to sort the array, and then I have taken a variable which is max loaded box count. So I have initialized it with 0 in the beginning, and then a for loop is there. So for each 1D box in box type, for each box, right, we want to so number of boxes, the box of 0 is going to have number of boxes, and number of units are box of 1. Then maximum size that we can load on the truck. So it is going to be the minimum of the number of boxes that we are currently having and the truck size which is given to us, right? So, and then maximum loaded box count will be incremented by the max size that we can load on the truck into the number of units in each box, right? And then truck size is reduced because we have already loaded some boxes on the truck, so it is going to be reduced by the max size that we have taken. And if by chance we hit truck size 0, then we can directly return from here only max loaded box count. And if this for loop ends, then we can just return the max loaded box count. So the time complexity is n log n for sorting, and order of n for traversing. So it's n log n plus order of n, so n log n in total.